Good morning, children. In the last class, we have discussed about important formula, some sample problems, and then electrons arrangement of an atom. These things we discussed, isn't it? Today in this class, we will discuss about limitation of Bohr's model, then progress of atomic model, followed by different quantum numbers, and then finally we will see about the electronic configuration of an atom. First, let me see about the limitation of Bohr's model. What is the meaning for limitation? Limitation is nothing but weakness. Okay, weakness of Bohr's atomic model. Bohr's atomic model failed to explain the spectrum of atoms other than hydrogen atoms. Okay, Bohr's atomic model failed to explain the spectrum of atoms other than hydrogen atom. So, what is the meaning for spectrum? Spectrum means when a beam of white light is dispersed, different colors are formed. These are called spectrum. At the same time, what do you mean by atomic spectrum? Atomic spectrum means when atoms are excited, they emit light with certain wavelengths, and that time different colors are formed, colors are produced. These are called atomic spectrum. Okay, so Bohr's atomic model failed to explain the atomic spectrum of atoms other than hydrogen atoms. Next, Bohr's atomic model could not explain the spectrum of atoms because it could not explain the spectrum when two spectral lines are very close to each other. This is also one of the weakness point of Bohr's atomic model, right? Bohr's model failed to explain the ability of atoms to form molecules by chemical bond. This is also one of the limitations. Bohr's atomic model could not explain the spectrum of multi-electron atom. Okay, what is meant by multi-electron atom? An atom which contains more than one electron are known as multi-electron atom, right? An atom which contains more than one electron, that is known as multi-electron atom. For example, helium as well as nitrogen atoms are referred as multi-electron atoms because this helium atom as well as nitrogen atom contains more number of electrons, and hydrogen is the only atom in the periodic table which contains only one electron, right? So Bohr's atomic model could not explain the atomic spectrum of multi-electron atom. Next one, why the angular momentum of the revolving electron is equal to nh by 2 pi. This has not explained clearly in Bohr's atomic model. Hence, this will come under the limitation of Bohr's atomic model. Already in the previous class, we have discussed about the angular momentum. So, L is equal to mvr, isn't it? Both are same only. So, this angular momentum, why the angular momentum of the revolving electron is equal to nh by 2 pi or mvr? It is not explained clearly by Bohr. Hence, it is one of the limitation of Bohr's atomic model, right? Next, Bohr interrelates the classical law of physics and quantum theory of radiation without any theoretical explanation. This was one of the biggest drawback of Bohr's atomic model. Okay, classical law of physics means it is nothing but group of physics theories, whereas quantum theory of radiation is the frequency. This is not explained clearly. Okay, so it is one of the drawback of Bohr's model. Right, these are some of the limitations of Bohr's atomic model. Okay, this is a 5-mark question. Right, children? Shall we move to the next one? Right. Next, we will see about progress of atomic models. Progress means development. Okay, progress means development. Many scientists have developed the atomic models. First one, we will see about John Dalton's atomic model. John Dalton was a famous English physicist, chemist and meteorologist. Meteorologist means one who is well versed in weather forecasting or foretelling. Okay, so John Dalton is well known for his atomic theory. In 1803, John Dalton proposed his atomic theory. He proposed that atoms were indivisible solid spheres. What is the meaning for indivisible? Indivisible means cannot be divided, cannot be cut, not able to be cut. That's the meaning for indivisible. So according to John Dalton, an atom was an indivisible solid sphere. Right? Next one about J.J. Thomson. J.J. Thomson discovered electrons. Okay. So J.J. Thomson proposed that J.J. Thomson discovered electrons, one of the subatomic particles, and he proposed to J.J. Thomson proposed that atoms are indivisible. That is, atoms are solid spheres of positively, which contains positively charged particle as well as negatively charged particle. Okay, atoms are made of positively, it is a solid sphere, it is made of positively charged particles and negatively charged particles. In that atom, electrons were embedded in it. Embedded means what? Fixed in it. Okay, electrons were fixed in it, just like the seeds of a guava fruit. You might have seen the guava fruit. Seeds were fixed in it, isn't it? So, J.J. Thomson resembled the guava fruit. Okay, resembled the guava fruit. In that guava fruit, some seeds were embedded in it. No, he resembled the electrons. Okay, so J.J. Thomson proposed that an atom was a solid sphere of positively charged particle and negatively charged particle, and electrons were fixed in it just like the seeds in a guava fruit. He compared, okay, he compared the electrons here, right? Next one, Rutherford. But this model, J.J. Thomson proposed that model, no, that model was proved wrong. Next one, Rutherford. Rutherford suggested the planetary model, but actually this planetary model was proved wrong because it did not explain anything about the arrangement of electrons in an atom. So this concept, whose concept? Rutherford's concept also proved wrong. Next one, Niels Bohr. In 1913, Niels Bohr proposed that electrons revolving around the orbits, in a different orbits with some fixed amount of energy. Okay. Based on this, he introduced the concept of different energy levels of atom. Okay. So in 1913, 1913, in 1913, okay, Niels Bohr proposed that electrons revolving around the nucleus, okay, nucleus is present at the center of the atom. So electrons revolve around the nucleus in a fixed orbit with some particular So based on this, we introduced the energy levels of an atom, right? Next one, Sommerfeld. Sommerfeld, he was a famous scientist. So in 1916, he modified, okay, in 1916, Sommerfeld modified Bohr's atomic model by introducing the elliptical orbits for electron path. Elliptical means it's just like a oval-shaped path. Okay. So in 1916, Sommerfeld modified Bohr's atomic model, Niels Bohr's atomic model, by introducing the elliptical orbits. Okay, for electron path of the electron. Next one, quantum numbers were introduced at that time. Okay, quantum numbers were introduced, and it is useful for distinguishing the orbitals. Orbital means it is nothing but a wave function. Okay, to distinguish the orbital based on their size, shape, orientation. Orientation is nothing but position. Okay. Size, shape as well as position of the orbital by using different quantum numbers like principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. I will explain you about the different quantum numbers at the end of this session. Right? Okay. Based on this introduction of this quantum theory, various rules are put forward for filling the electrons in the orbit of an atom. Okay, what are the various rules? The various rules are Hund's rule, Pauli exclusion principle, and Alpha principle. These three rules are very important. Okay, for the filling of electrons in an atom. Without these three rules, we cannot fill the electrons in the orbital. Okay, so those three rules are very important, right? Okay, finally in 1921, Bohr and Bury, both are scientists. Okay, Bohr and Bury, they gave a systematic plan for the arrangement of electrons in an atom. Okay, in 91 this year, as well as scientist name, you should learn, children. You can expect this in 1 mark type question or in mid-level questions. Okay, so in 1921, Bohr and Bury, they gave a systematic plan for the arrangement of electrons in an atom. By this way, the nature of electron is studied. Okay, the nature of electron we will discuss in the next video. Right. Now we will discuss about the three important rules. Okay. Yes. First one is the Alpha principle. Okay, Alpha principle. This Alpha principle was formulated by Niels Bohr. Okay, Alpha principle was formulated by Niels Bohr. This Alpha is not the name of a scientist. Okay, this Alpha is actually a German word. It is a German word, and the meaning for this Alpha is to build up. Build up. Okay, otherwise we can say construction. Okay, so Alpha principle states also a 1 mark question. Alpha is a German word, and the meaning for Alpha is to build up or construction. So Alpha principle states that, okay, Alpha principle states that the subshell with the minimum energy is filled up first. Okay, so Alpha principle states that the subshell with the minimum energy is filled up first, and when the subshell obtains maximum quota of electrons, quota is nothing but number of electrons. Okay, then the next subshell of higher energy starts filling. Okay, so Alpha principle states that in an atom or molecule, okay, in an atom or molecules or otherwise ion, the atomic orbital electrons will fill the atomic orbitals with the lower energy level first before filling the higher energy level. This is the concept behind the half-bar principle. So half-bar principle states that the subshell with minimum energy is filled up first. This line is very important. Minimum energy is filled up first, and when this subshell attains maximum number of electrons, then the next subshell with higher energy fills. Okay, first minimum energy will fill, followed by higher energy. This is the basic concept behind the half-bar principle. Okay, it is a very important 2-1 question. So half-bar principle states that the subshell with minimum energy is filled up first, and when the subshell attains maximum number of electrons, then the next subshell of higher energy starts filling. Okay. Next we can move to Pauli exclusion principle. Pauli was a famous Austrian physicist. Okay. Pauli was a famous Austrian physicist. So Pauli exclusion principle states that no two electrons can have the same 4 quantum numbers. Already I told you about quantum numbers. 4 quantum numbers are principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number. But in your book only 3 quantum numbers are given. When you come to higher classes, you will learn about the remaining 1 quantum numbers. Okay, so there are 4 quantum numbers. No two electrons can have the same value of 4 quantum numbers. Okay, and the next one, an orbital can accommodate maximum 2 electrons with opposite spin. So this is the orbital. This is the square box is the orbital, and these are electrons. Okay, so an orbital can accommodate means place. An orbital can place maximum 2 electrons with opposite spin. Here only 2 electrons only we can fill here. These electrons, it is in the opposite spin. Okay, it is in the opposite direction. The spin it is in the opposite direction. So an orbital can place maximum 2 electrons with opposite spin. So Pauli exclusion principle states that no 2 electrons can have the same 4 quantum numbers. Each and every quantum numbers, they have some integral values. The values will differ, I will tell you. Okay, so an orbital can accommodate only 2 electrons with opposite spin. Okay, this is Pauli exclusion principle. Next we can move to Hund's rule. Hund was a famous German physicist. He is well known for his work on atoms and molecules. Okay. So Hund's rule states that in case of filling the orbitals, in case of filling the orbitals with electrons, every orbital must be singly occupied. Every orbital must be singly occupied before the double occupancy starts. This is the Hund's rule. Okay, Hund's rule states that in case of filling the atomic orbitals of a multi-electron atom, every orbital, the electrons will fill singly, then only double occupancy starts. This is the Hund's rule. Multi-electron atom, already I told you. Electron which contains more than 1 electron, atoms which contain more than 1 electron are known as multi-electron atom. Okay, so Hund's rule states that in case of filling the orbitals with electrons in a multi-electron atom, every orbital must be singly occupied before the double occupancy starts. Okay, this is the Hund's rule. One more definition also. This definition is given in your book. This also you can work on same meaning only. So electrons learn that definition. Okay, exact definition I told you, right? Next one, we will move to quantum numbers. Before that, these three rules, Afka principle, Pauli exclusion principle, and Hunt's rule. These three rules are very important for filling the electrons in the orbital. Okay, so without these three rules, we cannot fill the electrons in the orbital. Based on this rule only, we can fill the electrons in the orbital, right? Okay, next we can move to quantum numbers. First of all, what is meant by quantum numbers? The total of 4 quantum numbers are required to describe completely the movement of an electron is known as the quantum number. Okay, so the total of 4 quantum numbers are required to define an electron completely. That is, completely we can define the arrangement of electrons or otherwise movement of electrons is known as the quantum number. There are 4 types of quantum number already I told you. First one is the principal quantum number. It is represented by the letter n. Small letter only you have to use. Okay, this letter also you should mention. Principal quantum number is represented by the letter n. Next one, azimuthal quantum number. It is represented by the letter L. Okay, L. Next one, magnetic quantum number, represented by the letter M. Whereas spin quantum number, represented by the letter S. What is meant by quantum number means you have to write the definition. It's enough. What are the different types of quantum number? If the question is asked like this, then you have to mention all these types and also you have to represent their symbol also. Okay, right children? Good. So quantum number means quantum number is generally it's the total of 4 quantum numbers are used to describe completely the arrangement or movement of electrons in an atom is called the quantum numbers, and 4 quantum numbers are principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number, right? Principal quantum number. It is represented by the letter n. So principal quantum number describes the size of the electron wave. Size of the electron wave. This line is very important. Okay. So principal quantum number is represented by the letter n. It describes the size of the electron wave and the total energy of the electron. Right? It has integral values 1, 2, 3, 4, etc. Right? So what is principal quantum number? Principal quantum number describes the size of the electron wave and the total energy of electron. Okay, you have to mention its integral values also. So maximum number of electrons which can be accommodated in each energy level is given by the formula 2n square. Okay, it's given by the formula 2n square, where n represents the number of energy levels. Okay, for example, if you take the K shell, its maximum capacity range, that is electrons to be filled, is 2 electrons only. Whereas for L shell, 18 electrons is the maximum capacity. Whereas M shell, it has 18. Okay. First for K shell 2 electrons, L shell 8 electrons, M shell 18 electrons, and for N shell 32 electrons. Not more than that you can fill the electrons. Okay. So that part is very important. Next we can move to azimuthal quantum number. It is represented by the letter L. So azimuthal quantum number describes the shape of the electron cloud. Okay, what we saw in principal quantum number, it describes the size of the electron cloud, whereas in azimuthal quantum number, it describes the shape of the electron cloud. Okay, and the number of subshells in a shell, and and the number of subshells in a shell. It can have values from 0 to n minus 1. What is the difference between shell and a subshell? Shell is a pathway followed by electrons around an atom's nucleus. This is shell. Then what is subshell? Subshell is the pathway in which the electrons moves within the shell. This is the difference between shell and subshell. Okay. So azimuthal quantum number describes the shape of the electron cloud and the number of subshells in a shell. Next one, magnetic quantum number. So magnetic quantum number describes the orientations of the subshell. Orientation is nothing but position of the subshell. Okay. So magnetic quantum number describes the position of the subshells. It can have values from -1 to +1 including 0. Each and every quantum numbers have value. Okay. So its value is -1 to +1 including 0. Magnetic quantum number describes the position of the subshells. Okay. Finally, we will move to spin quantum number. It is represented by the letter small s. So spin quantum number describes the angular momentum of the electron. Spin quantum number describes the angular momentum of an electron. Angular momentum already we saw, isn't it? Spin quantum number describes the angular momentum of an electron. So principal quantum number, it describes the size of the electron wave, whereas in next one is azimuthal quantum number describes the shape of electron cloud. For magnetic quantum number describes the orientation, that is position of the subshells, whereas spin quantum number describes the angular momentum of the electron. It's a 5-mark question, right? Good. It has values. The spin quantum number has values +1/2 as well as -1/2. Right. When you come to the next level, you can learn about how to apply the values for filling the orbital. Right. Next, we can move to orbital diagram. Orbital diagram is a pictorial representation of electrons. Okay. It mentions the pictorial, it represents the pictorial descriptions of electrons in an atom. Okay, that is the concept behind the orbital diagram. Okay, so look at this one. While writing the, we have to follow some steps for drawing the orbital diagram. Here, this square shape, it mentions the orbital, whereas these arrows mention the electrons. The upward arrow represents one spin direction, whereas downward arrow represents another spin direction. Right. So orbital diagram is first of all you have to, if you put the box like this, means the square shape mentions the orbital, and inside the square these two arrows, it mentions the electrons. Upward arrow mentions it spins in one direction, whereas downward arrow it spins in another direction. This point you have to keep it in your mind. And orbital, for applying this orbital diagram, 3 rules are very important. Already I told you. The first rule is Pauli exclusion principle, Afba principle, and another one is the Hunt's rule. These 3 rules are very useful for filling the orbital, filling the electrons in the orbital. So this part is very important, right? So next we can move to electronic configuration of an atom. Chemists use electronic configuration for mentioning the arrangement of electrons in an atom. Okay, that is the concept behind the electronic configuration. Electronic configuration, generally chemists use the electronic configuration to mention the arrangement of electrons in an atom. Right. While writing the electronic configuration, we should follow some standardized notation should be followed. Okay. For example, if you take the electronic configuration of 1s2, 2s2, 2p2. Atomic number of carbon is 6. Okay. So electronic configuration of carbon, it should be written like this: 1s2, 2s2, 2p2. For example, if you take this 1s1, okay, here this 1, it represents the energy level. This 1 represents the energy level. And here S is given. No, this S represents the type of orbital, whether it is a S orbital or P orbital or D orbital or otherwise F orbital. Okay. So this S mentions the type of orbital. And here superscript 1 is given, isn't it? So it mentions the number of electrons in the orbital. How many electrons occupied there? Okay. So this number, this is the superscript. This superscript mentions the number of electrons in the orbital, which is present at the orbital. So this 1 represents the energy level. S represents the type of orbital. This superscript mentions the number of electrons present in the orbital. So these steps we should follow while writing the electronic configuration. Got it, children? Right. Now we are going to see the electronic configurations of some important elements. Okay. So elements are given. Symbol is also given. Its atomic number of that particular element is given and electronic configuration also given. Let me see the element now. First one, hydrogen element. What is the symbol of hydrogen? The symbol of hydrogen is H. Okay. Its atomic number is 1. What is the atomic number of hydrogen? Atomic number of hydrogen is 1. Its electronic configuration is also 1. Okay. Actually, atomic number tells us the number of electrons present in an atom. So, in hydrogen element, only 1 electron is present. Right? Second one, helium element. Its symbol is He. First letter should be in uppercase and second letter it should be in lowercase. Right? And atomic number of helium is 2. Electronic configuration is 2. 2 electrons are present in helium atom. Next one, boron. Boron element. Its symbol is capital B. Atomic number of boron is 5. So the electron arrangement, it should be in the first shell 2 electrons will present and in the second shell 3 electrons will present. Okay. Next one is carbon element. Its symbol is C and atomic number of carbon is 6. In the first shell or first orbit, 2 electrons are present and in the second orbit, 4 electrons. So 2 plus 4, you will be getting the atomic number 6. Next one is nitrogen. Symbol is N and its atomic number is 7. Electronic configuration is 2, 5. Next one is oxygen. Its symbol is, oxygen symbol is 4. Atomic number is 8. 2, 6. This 2, 6 is the electronic configuration of oxygen atom. Next one is sodium. Its symbol is Na. Next one, atomic number is 7. It should be split into 2, 8, 1. Next one is magnesium atom. Its symbol is Mg. Atomic number is 12. So its electronic configuration is 2, 8, 2. So totally 12. Next one is sulfur atom. Sulfur, its symbol is S and its atomic number of sulfur is 16. Electronic configuration is 2, 8, 6. So you will be getting 16. And next one is the chlorine element. Its symbol is Cl. Okay, first letter C, capital C and L is small l. Atomic number of chlorine is 70. And what is the electronic configuration? It can be split into 2, 8, 7. Like this, we have to write the electronic configuration for all the elements. Okay, 20 elements are given in our book. The remaining 10 elements will get practice based on this, right? Now we will see the activity based on this electronic configuration. So look at this one. So this is here carbon element as well as nitrogen elements are present. Okay. So this is the electrons arrangement of carbon atom as well as nitrogen atom. Okay. So inside the first let us see the carbon. So this is the center part. Okay. Center part is nothing but nucleus. So what is present in the nucleus? Protons and neutrons are present in the nucleus. So this is the first shell or first orbit and this is the second orbit. Okay. So inside the nucleus what is present? Protons and neutrons are present. So this is the carbon element. What is the atomic number of carbon? The atomic number of carbon is 6, isn't it? So in the first shell already we saw the electronic configuration also 2, 4, isn't it? So in the first shell 2 electrons and in the second shell 5 electrons will be there. So for carbon atom only we are seeing now, isn't it? So carbon atomic number is 6 and its electronic configuration is 2, 4. So see the first orbit. In the first orbit how many electrons are present? 1, 2. 2 electrons are present. These are nothing but electrons which revolve around the nucleus in circular orbit. Okay. So in the first orbit 2 electrons are present. This is second one. In the second orbit see 1, 2, 3, 4. 4 electrons are present. So 2, 4. So you will be getting the atomic number 6. This is the electron arrangement of carbon element. Okay. 2, 4. Next one, let me see the nitrogen element. What is the atomic number of nitrogen? It is 7, isn't it? See, 7 means 2, 5. So this is the center part, nucleus. This is the first orbit and this is the second orbit. For this nitrogen atom, this is the outermost orbit. Okay. So in the first orbit, how many electrons are present? 1, 2. 2 electrons are present. And in the outermost orbit, how many electrons? 1, 2, 3, 4, 5. 5 electrons are present. Okay. Right. Next we can see the helium element. Helium, its atomic number is 2, isn't it? So electronic configuration also 2. So this is the center part nucleus. See, 2 electrons are present. This is the outermost orbit. So in the outermost orbit only 2 electrons are present. Next one, let us see the magnesium. For magnesium atomic number is 12. So its electronic configuration is 2, 8, 2, isn't it? So see here inner one orbit is here. This is the second orbit and this is the outermost orbit. So in the first orbit see 2 electrons are present and this is the second orbit. In the second orbit 2, 4, 6, 8. 8 electrons are present and this is the outermost orbit and in the outermost orbit 2 electrons are present. This is the electrons arrangement of magnesium atom. Okay, good. Next one, let me see the sulfur element. Sulfur atom. So what is the atomic number of sulfur? Sulfur atomic number is 16. So its electronic configuration is 2, 8, 6, isn't it? See, in the first orbit 2 electrons are present. In the second orbit 2, 4, 6, 8. So 8 electrons are present and in the outermost orbit 2, 3, 4, 5, 6. 6 electrons are present. Okay. Like this you have to write the electronic configuration of all the elements. Next one is chlorine atom. For chlorine, what is the atomic number? Atomic number is 70 and electronic configuration is 2, 8, 7. See the first orbit, how many electrons present? 1, 2. The second orbit, 8. 2, 4, 6, 8. 8 electrons. And in the outermost orbit count 1 plus 2, 3. 3 plus 2, 5. 5 plus 2, 7 electrons. Okay. Next one, let me see the oxygen element. Oxygen, there is oxygen, symbol is O. Its atomic number is 8 and its electronic configuration is 2, 6. Okay. So see, this is the first orbit. 2 electrons are present, and in the outermost orbit 2, 3, 4, 5, 6. 6 electrons are present. So 2, 6, right? Next one is sodium atom. For sodium, its atomic number is 11 and its electronic configuration is 2, 8, 1. See the first orbit 2 electrons, in the second orbit 8 electrons, in the outermost orbit only 1 electron. Okay, so this is sodium atom. Next one is lithium atom. For lithium, atomic number is 3. Okay, so in the first orbit 2 electrons are present. That's what 2, in the outermost orbit how many electrons are present? Only 1 electron. So 2, 1. Next one is argon element. Its atomic number is 18. So in the first orbit 2 electrons are present. In the second orbit 8 electrons are present. And in the outermost orbit 8 electrons are present. Okay. And finally we can see the hydrogen element and boron. This is the center part. Hydrogen, its atomic number is 1. So its electronic configuration is also 1. So see, only 1 electron is present in hydrogen atom. Next one, boron. For boron, its atomic number is 5. So its electronic configuration is 2, 3. See, in the first orbit, see how many electrons? 1, 2. And in the outermost orbit, 3 electrons. So 2, 3. Like this, you have to write the electronic configurations for all the elements. 20 important elements are given in our book. Okay, you have to complete all the remaining elements. You have to complete 10 elements only I told you, isn't it? The remaining elements you have to complete in this manner. Got it, children? Right. You will get your assignment today. Complete the assignment and go through what are the contents we have discussed today, and send your assignments through WhatsApp group, and also many definitions as well as many rules I have told in this lesson. All are very important. Okay, these are the basic things. So you should learn everything. The remaining things we will see in the next video. Thank you, children.